let us continue our topic. In the homework, I have given you exercise 5.2 to do the question 1 to 7 or 1 to 8. Let me explain the question number 9 and 10. They are somehow the different question. We have written so many results of the derivative of different functions, but we have not seen the derivative of the modulus function of the greatest integer function. Then how to find out the derivative of modulus function or the greatest integer function? Let us see by this question. Now the question is here, prove that fx equal to modulus of x minus 1. X belonging to R is not differentiable at x equal to 1. Whenever we have to find out the derivative of the modulus function, then in this question we have to take help of left hand derivative and the right hand derivative. If left hand derivative and the right hand derivative both are equal, then we can say the function is differentiable and that equal value is the derivative of the given function. Now in the 11th class we have introduced how to find out the derivative by using first principle is that f dash x equal to limit x tends to a fx minus fa upon x minus a. This is the what derivative of a function at a point. If this quantity is existing finitely, then we can say the function is differentiable. So by this method we will find out the left hand derivative and the right hand derivative. Let us solve this question. Now fx equal to modulus of x minus 1 and we have to find out the derivative at x equal to 1. Firstly we will find out the left hand derivative. As in the case of limit of the function we are finding the left hand limit. Same here in the case of differentiation we should find out the left hand derivative is equal to limit x tends to 1 minus fx minus f1 upon x minus 1. To find out the left hand derivative, we have to put x equal to 1 minus h. By putting x equal to 1 minus h in the function, we are getting here limit h tends to 0, f of 1 minus h minus, when I am finding f of 1, it is what? 0. So therefore it becomes f of 1 minus h minus 0 upon 1 minus h minus 1. Simplifying here, limit h tends to 0. Now f of 1 minus h is what? Modulus of 1 minus h minus 1. Putting this value here, minus as earlier we have seen, f of 1 is 0 upon minus h. Then simplifying this expression, we are getting here limit h tends to 0, modulus of minus h minus 0 upon minus h. Now limit h tends to 0, modulus of minus h is h upon minus h. Then it becomes equal to minus 1. So the value of the left hand derivative is equal to minus 1. Similarly, we will find out the right hand derivative. Then taking it limit x tends to 1 plus. Here the limit is x tends to 1 minus. Here the limit is x tends to 1 plus f of x minus f of 1 upon x minus 1. Again for the right hand derivative, we are putting x equal to 1 plus h. Then this becomes limit h tends to 0, f of 1 plus h minus f of 1 upon 1 plus h minus 1. Putting the values and simplifying here, we are getting here limit h tends to 0. Then putting here in the function modulus of 1 plus h minus 1. Again f of 1 is 0 upon h. Simplifying here, we are getting limit h tends to 0, modulus of h minus 0 upon h. Again the modulus of h is h. Then h upon h is equal to 1. Now here the left hand derivative is minus 1, right hand derivative is equal to 1. Now the left hand derivative is not equal to right hand derivative, so we can say the function is not differentiable at x equal to 1. This is the way to do the question of this. Let us see the question of the greatest integer function. Again here we have to find out, we have to check either this function is differentiable at x equal to 1 and x equal to 2 lying in the interval 0 to 3. We will do again this question by the same manner. Let us check the differentiability of the function at x equal to 1. Now here again we will find out the left hand derivative. Limit x tends to 1 minus f of x minus f of 1 upon x minus 1. Now putting x equal to 1 minus h here. Limit h tends to 0, 1 minus h minus 1 upon 1 minus h minus 1. Is it clear? Now let us simplify it here by the definition. Now when you're finding out here limit h tends to 0, when I am finding here the greatest integer of 1 minus h, then the greatest integer of 1 minus h, it means this value is lying between what? 0 and 1. Therefore, its greatest integer will be 0. This is the main point here. When I am finding the greatest integer of 1 minus h, now this quantity is lying between what? 0 and 1. Therefore, its greatest integer value is 0. Its greatest integer, the greatest integer of 1 is 1 upon minus h. Then putting these value here, it becomes limit h tends to 0, 0 minus 1 upon minus h. Minus cancel with minus, then 1 upon h. Now when h tends to 0, it means 1 upon 0, and 1 upon 0 is infinity because it is what? Positive infinity. Similarly, we will find out again the right hand derivative. Limit x tends to 1 plus f of x minus f of 1 upon x minus 1. Again putting here x equal to 1 plus h. Then it becomes limit h tends to 0. F of 1 plus h minus f of 1 upon 1 plus h minus 1. Again simplifying. Limit h tends to 0 and putting the value in the function. The greatest integer of 1 plus h minus greatest integer of 1 upon h. Now the greatest integer of 1 plus h. Now this value lying between here 1 and 2. Therefore its greatest integer value will be 1. Then it is what? 1 minus 1 upon h. 0 upon h is equal to 0. Now the left hand derivative, moreover, you can say it does not exist. And the right hand derivative is 0. Both are not equal. So the left hand derivative is not equal to right hand derivative. So therefore we can fx is not differentiable at x equal to 1. Similarly, we can differentiate at x equal to 2 and check its differentiability. This is how to do the question of this type. These are the two different questions from exercise 5.2 in which we have to find out the left hand derivative and the right hand derivative. Now again coming back to our chain rule, because our maximum differentiation in this very unit is by the chain rule. Let us differentiate the function. Differentiate y equal to under root x sin x. Now it can be written as x sin x whole power 1 by 2. Now when I am differentiating, I have to apply the chain rule. The first is the whole power. It means the derivative of this 1 upon 2 x sin x as it is 1 by 2 minus 1 into derivative of what? X sin x. Is it clear? Now here simplifying here 1 by 2, then 1 by 2 minus 1 is minus 1 by 2. This power can be written as 1 by 2 under root x sin x. Now when I am going to differentiate it, then we have to apply here the product rule. Now how to apply the product rule? First function as it is derivative of second plus second as it is derivative of the first. Then it becomes x into cos x plus the derivative of x is 1 second function as it is. So therefore it becomes here, therefore its derivative is what? X cos x plus sin x upon 2 under root x sin x. Now let us see the next question. The question is here, if y equal to this, find dy by dx at x equal to under root pi by 2. It means first we have to find out the derivative, then we have to put x equal to under root pi by 2. Now let us differentiate it easily. We can say we have to apply here u upon v. We have to apply here quotient rule to find out its derivative. Let us apply the quotient rule here. Now the square of this derivative here, then the second function as it is derivative of the first minus first as it is into derivative of the second. Is it clear? Now here this will remain as it is, or you can square it. Now here under root 1 plus x square as it is. When I am differentiating this sin x square, now the derivative of sin is cos. The first is here cos x square. Again the derivative of x square is 2x minus sin x square as it is. When I am differentiating this, it is what? Under root 1 plus x square. Then again 1 by 2 power here into 1 plus x square 1 by 2 minus 1 into derivative of inside function. It is what? Into 2x. Then simplifying the whole expression here, under root 1 plus x square cos x square into 2x minus sin x square into simplifying 2 cancel with 2 x upon under root 1 plus x square. Then just simplifying the numerator by taking the LCM, it becomes 1 plus x square into 2x cos x square minus x sin x square, and in the denominator collecting both the power here, it is what? 1 plus x square whole power 3 by 2. This we have done what? The derivative of the given function. Now in this we have to put x equal to under root pi by 2. Now here putting x equal to under root pi by 2 and simplifying here, we are getting dy by dx is equal to what? Minus 2 under root pi upon 2 plus pi whole power 3 by 2. This is how to find out the derivative of this function. This question can be asked in the exam either in the 2 marks question or even in the 4 marks question also. Now let us see the next question. Now find the derivative of this function. We have to find out. Now this function is the sum of 3 functions. Then what will do its derivative? Derivative of first plus derivative of second plus derivative of the third. Now let y equal to this, then dy by dx. Let us see, I am doing it very much directly. Now the derivative of first is, yes, the derivative sign is cos x square as it is. Then derivative of x square is 2x plus now sin square x whole power is 2. 2 here, 2 into sin x into the derivative of sin x cos x plus again it is here sin square x square. It means the chain of 3 function is there. One is whole power, another is sin, and that last one is x square. So it is what? First we have to take the power 2 as it is. Now here it is what? 2 sin x square, because 2 minus 1 is 1. 2 sin x square into next the derivative of sin is cos x square. Then the derivative of x square is 2x. See it again. Now the dy by dx in the first sin x square. The derivative of sin is cos x square. Then the derivative of x square is into 2x plus sin square x. It means sin x whole power 2. Then power is here 2. 2 sin x. Then the derivative of the function inside the bracket. The derivative of sin x is cos x. Plus again it is here the whole power. It is 2 sin x square. Then the derivative of sin cos x square. Then the derivative of x square is 2x. Then we can simplify and write down the result. Now here see again the differentiation of these questions I have taken from the element of mathematics, because differentiation is very much vast topic. We have a lot of practice how to find the differentiation by the chain rule, and this practice only we can do when you do the question from the elements. Now here differentiate y equal to sin cube 5x into cos under root x. Again it is what? The product of 2 functions. We have to use the product rule. Therefore dy by dx, the first function as it is, then the derivative of second, then plus second as it is derivative of the first. Let us differentiate it. Now this as it is. Now we have to differentiate it cos under root x. Now this is the first function, this is the second. For the first function this will remain as it is. Now the derivative of cos is minus sin under root x. Then the derivative of under root x, yesterday I have told you the derivative of under root x is 1 upon 2 under root x. You should remember it, because very much frequently we have to use the derivative of under root x. So derivative of under root x is 1 upon 2 under root x plus cos under root x as it is. Now we have to differentiate it. Here it is a chain of 3 functions. One the whole power, second sin, and third is 5x. Now very first we have to take the whole power. It will be 3 here. Now sin square 3 minus 1, 2. Sin square 5x. Then the derivative of sin cos 5x. Then the derivative of 5x is 5. Now simplifying here and putting all the values, simplifying here and then it becomes what? Minus here sine cube 5x into sine under root x upon 2 under root x plus 3 into 5 15 cos under root x sine square 5x into cos 5x. Now here sine square 5x is common and you can write down the remaining function inside the bracket. Now here see this question, one of the important question you can say in the differentiation as well. This type of question is asked in integration also, it will be there. Now here if y equal to this, we have to prove dy by dx plus secant square pi by 4 minus x equal to 0. One of the important question of the exercise. Now first we have to simplify this expression, then we have to prove the expression. Now let us see how to do the question here. Now first this one can be written as cos square x plus sin square x, and minus sin 2x can be written as 2 sin x into cos x. Similarly in the denominator again one can be written as cos square x plus sin square x, and sin 2x can be written as 2 sin x into cos x. We can make it a complete square using what? A square plus b square minus 2ab. It is what? A minus b whole square. Similarly in the denominator a plus b whole square. Then this is equal to what? Cos x minus sin x upon cos x plus sin x. Now in the expression we are having the secant square, and secant square is the derivative of tan. It means by one way or the another way we have to convert this into tan. Now how to convert it into tan? Let us see. Dividing the numerator and denominator by cos x, because we know sin by cos is tan. Now what we have to do here? First we have simplified, remove the square root, then we are getting this expression. Then now dividing the numerator and denominator by cos x, then it becomes cos x by cos x is 1. 1 minus tan x upon 1 plus tan x. Now in the 11th class we have done this result, 1 minus tan x upon 1 plus tan x using what? Tan a plus b, because tan pi by 4 is 1. So then therefore it is equal to, or moreover you can learn this result, 1 minus tan x upon 1 plus tan x equal to tan pi by 4 minus x, because when you open it we are getting this expression. So this can be written as tan pi by 4 minus x, and it is there in the result. Now here the only we are getting here y equal to this. Till now only we have to simplify the y. Now we have to differentiate it. Now let us differentiate it. Now dy by dx, the derivative of tan is secant square, this will be as it is pi by 4 minus x into derivative of what? Pi by 4 minus x. Then secant square pi by 4 minus x as it is. The derivative of pi by 4 is 0. The constant term, the derivative 0 minus 1. And then we transferring this term to the another side, we are getting the expression that we have to prove. Therefore, this can be written as dy by dx plus secant square pi by 4 minus x equal to 0. Is it clear to you? Now here, this we have proved. Let us see the similar question. Differentiate this. Again, we can suppose let y equal to this. Now here, secant x can be written as 1 by cos. We can put it in the numerator as well as in the denominator. Simplifying here, we are getting here 1 minus cos x upon 1 plus cos x. Now we know what is the result of 1 minus cos x. These two results are, you can say, the backbone of the differentiation and the integration. 1 minus cos x, 1 plus cos x. Now 1 minus cos x is 2 sin square x by 2. 1 plus cos x is 2 cos square x by 2. Then simplifying, it become what? Tan x by 2. Now y equal to tan x by 2. Therefore its derivative dy by dx is, the derivative of tan is secant square x by 2. Then the derivative of x by 2 is 1 by 2. Therefore this is equal to 1 by 2 secant square x by 2. Very much interesting question these are. Now here let us see another question. If y equal to a sin x plus b cos x, then show that this expression. So let us see how to do the question. The question is very much simple. Now y equal to this and we have to prove it. Therefore first we have to find out dy by dx. So simply dy by dx is what? A constant term as it is. The derivative of sin x is cos x plus b as it is. The derivative of cos x is minus sin x. Therefore it becomes a cos x minus b sin x. Now putting this value in the expression that you have to prove. First putting the value of y. Y is what? A sin x plus b cos x. Now putting the value here in a sin x plus b cos x whole square. Then putting the value of dy by dx. A cos x minus b sin x whole square. Then simplifying it here using a plus b whole square and a minus b whole square is a square sin square x plus b square cos square x plus 2ab sin x into cos x. Similarly, we can open the bracket here. It becomes a square cos square x plus b square sin square x minus twice ab sin x into cos x. Now these are the two terms, same term but in the opposite sign, they will cancel each other. Therefore, we left collecting the term of a square common, sin square x plus cos square x. Then b square common, again cos square x plus sin square x. Then it is equal, as we know, sin square x plus cos square x is 1. So therefore it is equal to a square plus b square equal to our right hand side. Hence, now here in the next questions, I am giving you some more result on the derivative of inverse trigonometrical function, and tomorrow we will use these results. So just see the result here. The derivative of sine inverse x is equal to 1 upon under root 1 minus x. Then the derivative of cos inverse x equal to minus 1 upon under root 1 minus x square. This is plus 1, this is minus 1. Similarly, the derivative of tan inverse x is equal to 1 upon 1 plus x square. Then the derivative of cot inverse x minus 1 upon 1 plus x square. Similarly, the derivative of secant inverse x equal to 1 upon x under root x square minus 1. And the derivative of cosecant inverse x equal to minus 1 upon x under root x square minus 1. Just see, these are the derivative of inverse trigonometrical function. Now you have to learn all these results, and tomorrow we should use